determination of alpha. First, let us study the apparatus used for finding the coefficient alpha, for volume coefficient alpha. In this figure, we notice a spherical bulb A. It is connected to a capillary tube F. A capillary tube F is connected to the spherical bulb. The capillary tube, it carries a side tube E through which we can insert any gas into the spherical bulb. And we notice a manometer, U-shaped manometer BCD. This manometer is connected to the spherical bulb with the capillary tube. The capillary tube attached to the spherical bulb is connected to the manometer at B. The manometer carries a tube, side tube T, through which we can draw the mercury inside the manometer. We can draw out the mercury from the manometer through the tube T, and the spherical bulb will be placed in a vessel, a cylindrical vessel, in which we insert a thermometer H to measure the temperature of the substance inside this cylindrical bulb. Then a constant water bath is attached to the manometer. The left end of the manometer carries a scale using which we can measure the volume of the gas inside the spherical bulb. The left side limb carries a scale. The right side limb is exposed to atmosphere. The mercury level inside the manometer is exposed to atmosphere in the right side end. So, the pressure over this mercury level will be atmospheric pressure. Like this, we have to understand the apparatus used for measuring the coefficient alpha. Let us recollect the apparatus briefly. A is spherical bulb, BCD is manometer, F is capillary tube, T is tap, H is thermometer, and alpha is evaluated by substituting the values of V0, Vt and T in the relation alpha is equal to Vt minus V0 by V0 into T. Now, determination of alpha, the procedure used for determining alpha. The relation that can be used for measuring alpha is equal to Vt minus V0 by V0 into T, Vt minus V0 divided by V0 into T. That means, we have to determine the volume of the gas inside the spherical bulb. We have to determine the volume of the gas inside the spherical bulb at two temperatures. One is at 0 degree centigrade, the other one is at T degree centigrade. But we have to see that the pressure on this gas is the same in both cases. We have to keep the pressure constant in the two cases. Now, let us try to measure the volumes at different temperatures. First, the spherical bulb will be placed between ice. The spherical bulb is covered with ice, and the levels in the limbs, the levels of mercury in the limbs B and D are made equal by opening the tap T. By opening the tap T, the levels of mercury in the limbs B and D, they are made equal. Since the level in D is at atmospheric pressure, so the level of mercury in B also will be at atmospheric pressure. Now, the volume V0 of the gas is measured with the scale on the limb B. The volume V0 of the gas is measured with the scale on the limb B. Now, the gas is at atmospheric pressure. The bulb is covered with a liquid at temperature T. The spherical bulb A is covered with liquid at temperature T, and the levels in B and D are equalized once again. The levels in B and D are equalized once again. Once again, the volume Vt is measured. The volume of the gas Vt is measured. This volume is also at atmospheric pressure because the levels are equalized. Once again, the pressure of the gas is made equal to atmospheric pressure and the volume Vt is measured. The temperature of the gas is measured with thermometer T. The initial temperature is 0 and final temperature is T. The volumes are Vt and V0. Initial volume is V0, final volume is Vt. So, we can calculate alpha with the relation Vt minus V0 by V0 into T. By substituting the values of Vt, V0 and T, we will get the value of alpha. Determination of beta pressure coefficient. Determination of beta pressure coefficient. First, let us understand the different parts of the apparatus. There is a spherical bulb B. The CD indicates a capillary tube bent twice at right angles, and there is a cylindrical tube is reservoir. Underneath it, it is a pressure rubber tube, and this reservoir is fitted to a stand. The reservoir is fitted to a stand, and then the spherical bulb and the reservoir, they are fitted to a vertical board, wooden board. They are attached to a vertical wooden board. Along at the center of the wooden board, we notice a scale, and the spherical bulb will be placed in a cylindrical vessel, and a thermometer is used to measure the substance inside this cylindrical vessel, and this vessel will be placed over a tripod stand so as to heat the contents of this cylindrical bulb. Here, the apparatus can be described like this. It consists of a spherical bulb B, which is connected to a capillary tube which is bent twice at right angles. Spherical bulb is connected to a capillary tube bent twice at right angles CD, and this capillary tube is connected to the reservoir with a pressure rubber tube which is filled with mercury. So, a part of the capillary tube and the reservoir will also contain mercury. The color part indicates mercury, and this reservoir is fitted to a vertical stand. The spherical bulb and the reservoir, they will be held against a wooden board. They are fixed to a wooden board. Along the center of this wooden board, there is a scale which is used to measure the levels of mercury. M and N indicate the levels of mercury, and the spherical bulb will be placed in a cylindrical vessel, and a cylindrical vessel will be placed on a tripod stand. The contents of cylindrical vessel, the temperature of the contents of the cylindrical vessel will be measured with the thermometer T. This is how we have to understand this apparatus. Once again, let us recollect the parts. B is bulb, T is thermometer, CD is capillary tube, M fixed mark on the closed limb, N mercury level in the open tube, and small h difference in mercury levels. Bulb, thermometer, capillary tube, fixed level M, N mercury level in open tube, small h difference in mercury levels. Now, the procedure. Keep the bulb B under ice. So, the cylindrical vessel with ice, then the bulb B will be under ice. Adjust the height of the reservoir till the mercury level in the capillary tube comes up to the mark M. Till the mercury level comes up to the mark M, which is a fixed mark. Then measure the difference in levels H0, measure the difference in levels, that is M and N. Let us call it as H0. Calculate the total pressure P0 with the relation P0 is equal to capital H plus small h0, where capital H is atmospheric pressure. Keep the spherical bulb B under water at a temperature T. So, fill this cylindrical vessel with water at temperature T. Once again, adjust the reservoir and bring the mercury level in the capillary tube up to the mark M. Now, measure the difference in levels of mercury M and N, call it as Ht, small ht, and then calculate the total pressure Pt with the relation capital H plus small ht. Now, evaluate beta from the relation Pt minus P0 by P0 into T. Calculate the value of beta with the relation Pt minus P0 by P0 into T. Like this, we determine the pressure coefficient beta. Calculation of beta. Calculate the total pressure P0 with the relation capital H plus small h0. Calculate the total pressure P0 which is equal to capital H plus small h0. Similarly, at temperature T, the total pressure Pt is equal to capital H plus small ht, and then substitute in the relation beta is equal to Pt minus P0 by P0 into T. This gives beta.